Okay, AP Calculus folks, this is Mr. McAllen speaking, and today we're going to talk about a quick video on how to set up an x-axis or a y-axis integral. And what I have here is a set of functions that we know pretty well. The red function is y equals x squared, and the blue function is simple y equals x. And if we want to find the trapped area, hopefully by looking at this picture, you can see that the top function minus the bottom function, if we integrate that from 0 to 1, this is 0, and the x-axis goes up to 1, top minus bottom, x minus x squared, dx will get us that trapped area. So let's see what that is. So everybody should remember how to anti-differentiate this. We have x squared over 2 minus this is x cubed over 3. Upper limit's 1, lower limit's 0, and we plug in our upper limit and subtract our upper limit from plug that in, and the second part is going to be just a zero case. So what we have here is basically 1/6 would be our final answer if we do the fractional math. Now, the point of this video is to show you how to set up a integral that would be on the y-axis. So what we want to do is in red, I will draw a y-axis strip. And we're going to let this strip go from on the y-axis 0 all the way up to y equals 1. And we have to transform our functions so that they're functions of y. So our new function would be x equals the square root of y. That would be our top function. And the bottom function is going to just be, if we solve for y, it's going to be y equals x again. The area trapped is the same in both cases. Trapped area is trapped area, so you shouldn't get a different answer for this. So the way you remember which is your top function when you're looking at sideways is this is the x-axis, and the x-axis points towards the higher value of x. So this would be our top function because it's it's higher in the x direction, and this would be our bottom function in this case. Our lower limit is 0 because along the y-axis, the direction of the y-axis, it dictates what our higher values of y are. So the way our limits are going to go is it's going to be from a lower limit of 0 to an upper limit of 1. Our top function is square root of y. Our bottom function is, again, this was y equals x or x equals y. So it's going to be, we have to write this integral in terms of y functions because unlike last time we were using a dx integral for along the x-axis. Now we're using a dy integral to be moving on the y-axis. We're going to add up all of these strips from 0 all the way up to 1. And we're going to do our anti-differentiation now. So remember, square root function is going to be written as the half power minus y dy from 0 to 1. All I did was I transformed square root of y to its power function. So now we have y. We're going to anti-differentiate it. It'll be 3/2. We're going to multiply that by 2/3. And then we're going to subtract from that y squared over 2. And remember, we evaluate for this from 0 to 1. So when we plug in our 1 value, we're going to get 2/3 minus 1/2 minus a 0 value when we put 0 in. What's 2/3 minus 1/2? It's 4/6 minus 3/6, which results in the same exact answer that we got before. Hopefully this is helpful for you to understand how to make a y integral and an x integral with the same trapped area. Remember, the key points are you have to be able to switch the function to a function of y, and you have to be able to identify which is the top function, which is the bottom function, and you need to figure out what your upper and lower y valued limits are. Let's look at another example. I prepared another one where this, in this case, is equal to, this is still y equals x squared, but the function is y equals 2x this time. Clearly, you can see the points of intersection are at, we have 2, 4 for that point, and 0, 0. So if you were to integrate this along the x-axis, you would have an x-axis strip. It'd be dxy, and the height of the function would be, or the height of the trapped area would be 2x minus x squared. So let's integrate that. I'm going to integrate from a lower limit of 0 in the x-axis to an upper limit of 2. My top function is 2x. My bottom function is x squared. Don't forget the dx. When I evaluate it, I have x squared minus x cubed over 3 from 1 to 0, and this becomes 1 minus 1/3 minus the whole quantity when I plug 0 in, and that's going to be 0 because 0 squared minus 0 cubed over 3. I end up getting, with the fractional math, my final answer is going to be 2/3 of a unit. What I want you to do is, with the same picture, I want you to come up with the y integral. And I'm going to just change over to blue ink, and we're going to consider the y integral going this way. That would be dy, and I want you to come up with what that y integral would be. I'm going to pause the video now, and I want you to try it. Okay, and I'm back, and I hope you can see here that I changed my function, the blue function, to 1/2 y equals x, and the other function is x equals root y. This is the top function because it's more in the, it's higher up on the x-axis, so I'm going to have root y minus, and this is my lower function, y over 2. I'm going to integrate this time from 0 to 4. And when I do that anti-differentiation, I'm going to get y 2/3 y to the 3/2 minus y squared over 6 over 4, my bad. This should be 2 times 2 because it was y over 2. Now you put another 2 in the bottom. I'm going to evaluate it from 0 to 4. And in this case, I just have to write everything out because it's a little bit more tricky than plugging 1 in. 2/3. This will be 4 to the 3/2 power minus 4 squared over 4. That's the upper limit evaluated, minus, if I evaluate it lower limit, I'm going to have 0 minus 0 because I'm plugging 0 into both. So we lucked out on that part. And so the half power of 4 is 2. So, and then 2 cubed is going to be 8. So I have 2/3. This quantity is going to be equal to 8 minus, I have 16 over 4, which is 4. So I basically have 16 over 3 minus 4. If I change 4 to thirds, 16 over 3 minus 12/3 will give me, hold on, 4/3. So I go up and I compare the answers, and I'm off. Let me see, what did I do wrong here? Okay, I'm going to pause the video and figure out what went wrong because we should get the same area. Okay, I figured out what I did wrong. I had not paid attention to my limit that I had to plug in. So let me just correct that. So for the first one, I had plugged in 1 instead of 2. So I should have, when I plug 2 in, I get 4 minus, and now I'll have 8/3. So the answer to that would be 16, I'm sorry, I want to go 12 over 3 minus 8 over 3 is going to be 4 over 3. And now I match up with my original, not my original, but the answer that I got with the y integral. So as you can see, you should get the same integral, the same area under the curve, depending, no matter if you do it with a y integral or an x integral. Hopefully this video has helped, and I look forward to hearing your comments tomorrow. I apologize for the error on the upper limit, but that just goes to show you not to, haste makes waste, and you should always, double check your answers. So anyway, look forward to hearing your comments. Have a good day.